Good day, guys. Today we will learn how to set up a potentiometer or a pot on a breadboard. You can call it a pot, not the pot for planting, okay? So this is a different pot. So potentiometer is just too long for most of people. That's why they call it pot for short. Alright, so here is our video on how to connect the pot on a breadboard. Here is our pot with its 3 arms, 1, 2, and 3. We can bend the arms or leads, whatever you want to call them. So it looks like a rake there. So we do this so that we can insert the pot on the breadboard in such a way that it will lie on it, so that it will be easy for us to turn this part of the pot. So basically this is connected to sorry for that, connected to our signal arm, the arm 2. Now here is our circuit diagram. This is the pot, arm 1, 2, and 3. 1, 2, 3. Okay, and here is our resistor, the 1 kilo ohm resistor, this one. Okay, so this lead of the resistor will be connected to the signal arm or arm 2, and the other lead will be inserted to any hole not connected to any of the 3 leads of our pot. Okay, and now we insert our LED. This is our LED. Here it is. Take note that LED has one long lead and the other is shorter. The longer lead is always positive, so here is the positive lead. This one is the positive, so it must be connected to our positive terminal of the battery. This is positive, this is negative. Okay, so this is the positive, that is the negative. So the negative is connected to the arm 2, positive must be connected to the positive power bus there. Okay, so that's our positive power bus. Okay, close-up view so that you can see how we assembled our circuit, but it's not yet done. We need another connection, this one, to finish it up. Okay, so we need another jumper wire. Here, and we insert that, connecting to the third arm and going to the negative power bus. Okay, so this is positive, that is negative. Now we're ready to connect our battery. Okay, so powered up. Now let's start from the left side. Okay, so here, that the middle position, then all the way to the other end, like that. Okay, so observe the brightness of the LED. Now, what is going on here? Okay, now, so we shut it down. As we turn the knob or the signal arm clockwise all the way to the end, it goes brighter, right? Then going the opposite way, it goes dimmer until it shuts down. Okay, so as we turn it clockwise, we are choosing a higher voltage, the maximum all the way. Okay, in this case it is 9 volts. When you go to the other end, we have 0 volt. Okay, so that is why a pot is also known as a voltage divider, because it allows us to select the voltage that we want to supply our load. In our circuit, our load is the LED. Okay, now here, the next part of our video, we are trying to transfer our LED so that we can make this circuit diagram. Okay, so we just simply transfer it. Okay, there. So still our resistor is connected to our signal arm. Now, observe. Okay, it's not yet working. We need to interchange the battery connection. There we go. Okay, so turn it clockwise. What is happening? Okay. See the difference? This time it goes dimmer, but when you go the other way, clockwise, counterclockwise, it goes brighter, like this. Okay. So what happened? So when we reverse the connection, or when we transfer the LED, we made our pot to change the voltage. Going to the minimum when we do it clockwise. Okay? When we go counterclockwise, we are choosing the maximum voltage. So we are increasing the voltage up to 9 volts. See the effect? Now, how does it do it? Okay, so how does a potentiometer work? Okay, so let me draw. For example, this is our battery, the 9 volt battery. Here is our potentiometer. Arm 1, arm 3, and here is our arm 2. Arm 2 is connected to our 1 kilo ohm resistor. Then the 1 kilo ohm resistor is connected to our LED. Then the other lead over the LED is connected to the negative terminal of our battery or signal, or the arm 1 of our pot. Now, this is our first setup, number 1. first part of our video. So when we turn it clockwise like this, our LED became brighter, right? Became brighter. This is because we chose an increasing voltage from 0 to 9 volts. So here in this point, we have the 9 volts. Here we have the 0 volts. Okay, so if we move this signal arm going to the 0, or going closer to arm 1, we are choosing a lower voltage up to 0 volts. So why 0 volts? Because this end of our circuit, so this is our load, the circuit load, this end is already connected to 0. This is the maximum 9. And the other end of the circuit, if you connect that to the 0, so 0 and 0, is there any difference? None, right? So the potential difference is 0 volt. So this bulb will not light up. Okay, it will not light up. But if we turn, let me just erase this one. Let me simplify that. Okay, so this is our LED resistor signal arm. Now if we choose the middle, we are choosing half of the maximum voltage. So half of this is 4.5. Okay, so from here going there, we have increased our voltage to half of the maximum, which is 4.5 volts. So this time it will light up. The brightness is gradually increasing. So from 0 to 45, we have increased the voltage, meaning we also increase the current according to Ohm's law. Now, what about if we move it even higher? Okay, so we go to the maximum 9. Okay, so here we have 0 volts, then we choose the maximum 9 minus 0, then we have, of course, a potential difference of 9 volts. So we have increased our voltage up to the maximum. We cannot go higher than 9 because that is only the voltage that our battery can provide. Okay, we cannot go more than 9. So the bulb will get even brighter because we have further increased our current. Okay, the current is now increased. So I hope I cleared it out how a potentiometer works on first part of our video. Now we go to our next part. Okay, so here we transferred our LED to the other side. So we connected the LED across 2 and 3. A while ago we connected it across 2 and 1. So this time we connect it across 2 and 3. Okay, so in this case, this lead of our LED is connected to this junction, and this is our, what do you call this again, the signal arm. Okay, so here how it goes. This time, as we turn it counterclockwise, so from here to here, so we move the signal arm to this direction. Can we say that we chose 0 volt? I think not. Let's look at here. So we have here a potential and another potential here. So these two leads, this one and this one, will be connected across this resistor. Okay, this resistor or resistance material of our pot. So at both ends we have a difference of 9 volts. Okay, 9, 0, or you can also say this is 0, this is 9. Okay, so from 0 we go to 9. Okay, so 0 and 9 has a difference of 9 volts. So there is a reverse effect on the brightness of the bulb. As we turn it counterclockwise, we are now increasing the voltage. Okay, as we go clockwise, we are decreasing the voltage. Increasing the voltage means increasing current. Decreasing the voltage means decreasing the current. So if we turn it counterclockwise, like this, counterclockwise, we are choosing a higher voltage, up to 9 volts. So it goes brighter. Our LED becomes brighter. When we turn the signal arm clockwise, we are decreasing the current because we are decreasing the voltage. Okay, so our LED becomes dimmer until it shuts off when we choose the 0 volts. 0 volt. Okay. So I hope I cleared out this part of our video. This is number 2 across 2 and 3. A while ago in part 1 of our video, this across 1 and 2. Okay, so thank you very much.